Hi, this is Kevin from the Mathsaurus, and in this video we're going to look at question 4 of the Oxford Maths Admission Test from 2019. This is a question that actually requires a bit less writing, I think, than some of the others, but by no means does that make it an easier question. In fact, I think there are parts of this question that are really very tricky because it's really asking you to think about the concepts. As I say, if you get those concepts, you can write the answer pretty quickly and efficiently. But there are a couple of parts in here that are pretty tricky, so I hope it's useful in preparing. Please put in the comments if you've got any other nice ways of answering any parts of this question. Otherwise, don't forget to check out the rest of this playlist. I'll do the whole of the 2019 paper in time for the 2020 exam, I hope, and I've got questions from the 2016, 2017 and 2018 papers as well, so have a look at the website below where they're all linked. Please do like the video and subscribe to the channel if you haven't already. You'll get notifications when I put the next videos out if you click the bell icon, and either way it really helps me get this content out there. So I hope this video is useful, and I'll get on with question 4. So in this question we're going to consider subsets S of the xy plane and points AB which may or may not be in S, and we're going to be interested in points of S which are nearest to the point AB. Right, so I've got some region, some subset of points, and I want to think about some general point here and say, okay, well, which point of this set is closest to AB, right? But we're doing that in some particular cases. So it says in part 1, let S be the disk x squared plus y squared is less than or equal to 1. So we've just got a circle with unit radius here, and S is the interior of that disk, and it says for a given point AB, find the unique point of S that's closest to AB, and we have got to consider these two cases carefully, where a squared plus b squared is greater than 1 and where a squared plus b squared is less than 1. Well, firstly, if a squared plus b squared is less than 1, that means we're, AB, this point AB is somewhere inside the circle, right? So that just means that the point itself is going to be the closest point, right? So that's kind of easy, right? So if a squared plus b squared is less than or equal to 1, then clearly AB is the closest point, right? So the only case that's at all challenging here is if I take the point AB somewhere outside of the circle, and then we can see that clearly the closest point here is going to be the one where, okay, so if that was a straight line, where that straight line through the origin intersects the circle is going to be the closest point. So we'll just work out the coordinates of that point. So okay, so let's say if a squared plus b squared is greater than 1, then we want the intersection of the line y equals, and then the gradient of this line is just going to be b over a, so this is y equals b over ax, and the circle x squared plus y squared equals 1, right? So if we substitute that in, we get x squared plus b squared over a squared, x squared equals 1, and so x squared 1 plus b squared over a squared equals 1, so we've got that x squared is going to be equal to, well, if I put this into a single fraction, this would be a squared plus b squared over a squared, so we're going to have a squared over a squared plus b squared, so x is the square root of that. Okay, and then y is going to be b over a times x, which is b over a times a squared over a squared plus b squared, all square rooted. So that just gives us the square root of b squared over a squared plus b squared. Now, the one thing we've got to be careful of here is that I've taken the square roots, and actually, of course, this should be x equals plus or minus, and this should be y equals plus or minus, right? Now, so, and if you think about it, the closest point here is the x coordinate is going to have the same sign as a, and the y coordinate is going to have the same sign as b. closest point is just going to be a over the square root of a squared plus b squared, b over the square root of a squared plus b squared, and in the four, you can think about it in each of the four different quadrants if you like, but that's going to resolve all the different cases with the signs being correct. Okay, so part 2 I think is actually an exceptionally hard problem for a math paper, and it's only 1 mark, and part 3 is only 1 mark, although you don't know that because I don't think they didn't say that in the questions, they just say it in the mark scheme. But it says describe an example of a subset S and a point AB such that there's no point of S nearest to AB. And I've put this alongside part 3 because it's the same question, but where the answer is more than 1 point, right? So we're really distinguishing between these cases. So actually in the first part we've got to have one where there's actually no point at all, right? So when I thought about this first, you think about part 3, and actually, in part 3 I'm going to do first here is slightly simpler in a way, right? And actually if we let's stick to the unit circle example before, right? If we just make the exterior of the circle, so x squared plus y squared is greater than 1, right? Say greater than or equal to 1, the set S, right? And then I just, for example, took the point 0, 0, or the origin as the AB, then every point on the circle is just as close as any other. So there's more than 1 point that's nearest to AB. Okay, so that does part 3. Now for part 2, what we want to say is something like make S x squared plus y squared strictly less than 1. Okay, so actually, I'm still doing this unit circle. You could take things that are not a circle if you want to, right? But now I don't include the boundary of the circle, right? So when I look at a point AB, well, the closest point is still the one that we were looking at before, in a sense, right? There's no other candidate that could be the closest point. But on the other hand, because I'm not including the boundary of the circle, that point isn't actually in the set S. So that's how we construct a case where there's no point of S nearest to AB. I think that's a tough question for the mat, but well done if you got it. Right, so part 4, it says let S denote the line with equation y equals mx plus c, obtain an expression for the distance of AB from a general point x mx plus c of S. So let's just have some axes here, and we'll put a general line on here. Okay, so right, so a general point on this line can have coordinates x and mx plus c, and then if I go to some distance, some point AB here, the distance between these 2 points, just by Pythagoras theorem, the distance squared here is going to be b minus mx plus c squared plus a minus x squared, and obviously you could put those individual terms in the other way around if you want, so we could say mx plus c minus b squared or something, and x minus a squared, whatever you want. So the distance here, it keeps trying to correct my writing here, so I just get the distance as the square root of that. Okay. So now it says show there's a unique point of S nearest to AB, and one thing we can say here is that if we look at this as a quadratic, it's a quadratic in X here, and so it is going to have a unique minimum point as a positive quadratic. Once we multiply it out, the coefficient of x squared will be positive. So that's one way to answer the end of this, but there's also something sort of slightly obvious about this fact, right? If you take a point AB, well, the closest point on the line is just, you just drop a perpendicular, and we kind of know that that's the closest point. So I think you might be able to get away with a more intuitive answer there from the geometry, but given that they've asked you to write down the distance for the general point, perhaps it makes sense to make an algebraic argument. Okay, part 5 it says, now this is quite hard as well, for some subset S and any point AB, the nearest point of S to AB is given by this expression here, right? So what we're going to do here is I want to describe what subset S is. So let's just think of this as x comma y, right? So I've got a plus 2b minus 2 over 5 is the x coordinate. We've got 2a plus 4b plus 1 over 5. Yeah, OneNote keeps making suggestions that are very unhelpful while it thinks I'm trying to write. I'm not sure why. So this is x and this is y. So let's think about what this means for the point, right? So can I come up with, if I can come up with like some relationship between x and y here, I can think of this as like as a locus of points x and y that satisfies a certain relationship. If I can kind of eliminate a and b from these expressions and just write it in terms of x and y, perhaps I can do something sensible here, right? So, and we do get lucky here, so we have a plus 2b equals 5x plus 2, and from this one we get 2a plus 4b is equal to 5y minus 1, and we see that this second one is exactly double this first one, right? So actually we have that 5y minus 1 is 2 times 5x plus 2, so 5y equals 10x plus 4 plus 1 is 5, so I've got y equals 2x plus 1, right? So so y equals 2x plus 1 is the subset S. The only extra argument we might want to make here is just to make sure we can get this whole line for points x and y. So to say something like, you know, as you vary a over different values between, I don't know, minus infinity and plus infinity, I suppose, you might get all the different possible values of x as well between minus infinity and plus infinity. So it is possible to get every point on this line. You could write that as a little bit of an ending there. Okay. Right. Okay, I've realised why OneNote is doing this funny thing and I've turned it off, so hopefully we won't get that anymore. Now, part 6, it says, say now that S has the property that for any 2 points P and Q in S, the line segment PQ is also in S. Show that for a given point AB, there cannot be 2 distinct points of S which are nearest to AB. Right, okay, so I'm not going to write this out in full, I'm just going to show you the argument here. So let's say I've got my S with this property. Actually, I've immediately drawn an S that doesn't have the property because I could here choose 2 points, right, like here and here, where the line segment between them doesn't stay in S. So let's draw a more typical set of this form. And let's say if I put point P here and point Q here, so we've got a set where the line segment is wholly contained in the set. Right, so okay, so effectively what we're going to do is suppose P and Q are both the closest point, right? Well, and I've got some AB, maybe it's here inside the set, maybe it's outside the set. It doesn't, you know, it doesn't really matter, right? But we showed in part 4 that there has to be a unique point that's you know, on this line that's closest to AB. And you've got to be a little bit careful here, because in part 4 we showed this for a line which is necessarily infinite, and here I'm thinking about the line segment instead. Okay, so in a way, you know, the argument we'd like to make here is just that, like, when I drop I can sort of drop a perpendicular, and this point, you know, that actually this point here must be closer than either P or Q, but we have just got to be a little bit careful about that case, you know, where maybe AB is out here, and when I drop the perpendicular it's not actually on my line segment anymore. Now, clearly, of course, now Q is closer than P, But perhaps to make a slightly more robust algebraic argument here, you can invoke part 4 and say that we know the general distance from AB to points on this full line is a quadratic, and so it has a minimum distance somewhere, but and even if it had equal values at P and Q, it's going to have a lower value somewhere in between, right? So in this case, that's not the case, right? Q is going to be the closest point. So either P or Q is closer, but supposing they're not, so supposing the distance between them is equal, then actually we are in this case, and so there is a closer point between them. So I think you could probably get the marks here either by drawing some pictures like this and making sure you've considered all the cases, or by invoking the algebra from part 4. But either way, that's the intuition, and you just need to write that out as a nice clear answer. So I hope that was useful. Don't forget to like the video and subscribe to the channel if you haven't already. I'll be putting question 5 and the rest of this paper out as soon as I can. And don't forget to check out all of the other ones I've done for this paper and others, either in the rest of this playlist or over at the Mathsaurus website, where everything is linked.